Hello friends, welcome back to the another video lecture of ATS subject. In this video lecture, we are going to learn about your third unit, which is divide and conquer algorithm. In that, we are going to learn about min-max problem. Okay, so for that, we have to understand what is actually a divide and conquer technique. So divide and conquer technique will divide your problem of size n into problem of n by 2 size. Means you will divide your problem into two parts. Further, that part will be divided into other two parts. This process will be continued until your size of n is feasible for dividing. After that, if your problem is divided into size n by 2, then we will have to solve that sub-problem. And after solving all sub-problems, we have to merge that solutions. And after merging that, we will get our final solution of your original problem. So that is the actual technique of divide and conquer. Okay, so by that we have our divide and conquer techniques algorithm here. So if our P is too small, then we will deduct P as our solution. Otherwise, we will divide our P into other P1, P2, P3 up to Pn parts, where n is greater than or equal to 1. Okay, so after that we will apply the solutions, means P1 solution, P2 solution, P3 solution, and we will combine their whole solutions. And after combining, we will return. So there will be a recurrence relation. It will be Tn is equal to Gn, where n is equal to 4. So Gn will be summation of Tn1 plus Tn2 plus up to Fn, when n is sufficiently large. Then and then we will divide, otherwise we will not divide. Okay, so for that our solution, or we can say our time complexities, will be n raised to k in case of 1 is less than p raised to k, n raised to k log n in case of 1 is equal to b raised to k, and time complexity will be n raised to log 1 at the base p in case of 1 is greater than p raised to k. So here our solution are from the equation Tn is equal to 1t n divided by b plus. Okay, so that is the equation of divide and conquer technique, and this is the cases for finding time. Okay, so let's proceed for our min-max algorithm. So min-max algorithm is on your screen. There will be three main parts. First part is dividing your numbers, or you can say your elements, into two parts, and proceed further up to your divided part is sufficiently large. Okay, so this algorithm we will back to it after explaining example. Okay, so let's take an example. Our example is we have different 9 numbers, which are 50, 40, minus 5, minus 9, 45, 90, 65, 25, and so on. So min-max problem is a problem for finding minimum and maximum number from our given list. So we have to find minimum number and maximum number from one list. So our step number 1 is divide these numbers into two parts. So for it, we will divide these numbers by this equation. Mid is equal to I plus j divided by 2. Okay. So here our I is equal to minimum index and j is equal to our maximum index. So 1 plus 9 divided by 2 means 10 divided by 2. So our first part will be 1 to 5 and second part will be 6 to 9. So our first sublist is 1 to 5 and second sublist is 6 to 9. Okay. After it, we will divide our these two sublists into another sublist. So for it, this first sublist will be divided into two parts again. Equation is again mid is equal to I plus j divided by 2. So I is equal to 1 and j is equal to 5. So 1 plus 5 means 6 divided by 2 means 3. So our first sublist will be 1, 2, 3 and second sublist will be 4, 5. Same as this case, we will divide our second sublist into two parts again. First sublist is 6 and 7. Second sublist is 8. Okay. So we can divide our this sublist into two parts again. So for it, we will divide our this sublist into two parts. 1 plus 3 divided by 2 is 4 divided by 2. So first sublist is 1 and 2. Second sublist is 3. And other sublist is not divisible. Okay. So after dividing our sublist, we can find our minimum and maximum numbers from it. So here for this sublist 40 and 50, we can find our minimum number and maximum number. And for this sublist, we can find our minimum and maximum number. So here 50 and 40. So our minimum number is 40, maximum number is 50. And here minus 5 is only entry. So minimum is minus 5 and also maximum is minus 5. Okay. So in next case, we will merge the two sublists again. So our total elements will be 50, 40 and minus 5. So from that we can know that our minimum number is minus 5 and maximum number is 50. Okay. So in this sublist, our minimum number is minus 5, maximum number is 50. After it, we will merge its another sublist, which is this 4 and 5. So in this 4 and 5, minimum number is minus 9 and maximum number is 45. If we merge this 1 to 5 sublist again, then from that case, our minimum number will be minus 9 and maximum number will be 50. This is the solution of our only sublist 1. We can find solution of our sublist 2. In our sublist 2, here for 6 and 7, our minimum number is 65 and maximum number is 9. For this sublist, our minimum number is 25, maximum number is 70. So, if we merge these two sublists, our minimum number will be 25 and maximum number will be 90. Okay, so we have find solution of sublist 1 and solution of sublist 2. In final case, we will merge these two sublists again and will make our final solution. So after combining or merging these two sublists, we can find that our minimum number is minus 9 and maximum number is 90. So this is the working of min-max algorithm. Okay, so now we can learn this thing. First is we have to pass in our algorithm max min value I, j, max and min. I will be minimum index, j will be index. Okay, so if I is equal to j, means this case I is equal to j. For 3, I and j both equal to 3. Okay, so our max and min will be a of j. So here max and min both are minus 5. If I is not equal to j and it is I is equal to j minus 1. So we will have to do, if a of I is less than a of j, then maximum is a of j and minimum is a of I. Means this is I and this is. So if your a of I is greater than a of j, you can see here a of I is greater than a of j. This condition is 4. So we will do max is equal to a of I and min is equal to a of j. If this case is right, then our a of I will be max and a of j will be minimum. If we have this case 8 and 9, if a of I is less than a of j, so here if a of I is less than a of j, then a of j will be max and a of I will be min. A of j will be max and a of I will be min. Okay, so in this case we are dividing our sublist and making it with mid value. So mid is I plus j divided by 2, and we will pass our these values into two recursive calls. First is min max val I, mid, max and min, and second call is mid plus 1 and j. So here we can see if we divide our sublist, then in first call we will pass 1 and mid, means we will pass our 1 and 5, and in second call we will pass mid plus 1 and j, means our 6 and 9. So after it we will find our maximum values and minimum values with updated values. So after it, if for each calling we will get our updated values, and after combination of that values we will find our final minimum and maximum value for this problem. Okay, so this is min max algorithm. Okay, so for min max algorithm, this is it. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, friends.